Section 7.3, trig equations. So the first equation I'm going to give you is this one here, cosine of theta plus 1 equals 0. So the first thing we try to do is we try to get one trig equation equaling to a number, and this is for the most part all of the problems. So the way I'll start is subtracting 1 from both sides. So now we get the cosine of theta equals -1. So what we can do from here is we have to think of the idea of the unit circle. So I just draw a little diagram out here. This is x, this is y. Okay, and the idea here is I have 0 to pi halves. Okay, this is pi. This is 3 pi halves, and then back around is 2 pi. So this is the idea of that unit circle, that circular thinking for trig functions. So what I'm looking at here is I'm going to try to find the angle measure where cosine of theta equals -1. So I do have to understand these triangles. So what I'll look at here, and this is just from memory in a sense, we did a little bit of this in class as well. So when I think of the idea of -1, if I drew a line here straight across, I know the cosine of 0 is 1. Then if I'm up here, the cosine of pi halves is 0. And then if I come around here, the cosine of pi is -1. So if we think of our answers, our answer here is going to be theta equals pi, because cosine of pi equals -1. So that would be our answer. Now again, for this problem, I didn't tell you, but the restriction was from 0 to 2 pi. So therefore, we only get this single answer. Now let's try another problem. So I'm going to erase this one here. And we'll start with the equation 2 sine squared theta minus 1 equals 0. So it's the same idea here. Essentially, I'm trying to get a single trig function equaling a number. So what I'll do first is add 1. So now I have 2 sine squared theta equals 1. Now, to get just a single trig function, I would have to divide by 2. So I get the sine squared of theta equals 1/2. Now I square root both sides because I want to get to the sine. So keep in mind, when I square root, I end up with plus or minus. So on the left, I get sine of theta, and on the right, I get plus or minus, really the square root of 1 over the square root of 2, because we know radicals can split across multiplication and division. And this simplifies to sine of theta equaling plus or minus 1 over square root of 2. Now, these values hopefully look familiar to us for these radicals. So what we're going to do is just think of the unit circle again and think about this. I can get a positive or negative ratio. So this tells me I can actually be in all 4 coordinates or 4 quadrants. So then in the first quadrant, think about this. Sine of theta is opposite over hypotenuse. So this is going to be a 1 here, and this is going to be a square root of 2. Okay, and then in the second quadrant, I get the same thing. So 1 and square root of 2, because remember, it's opposite over hypotenuse. This is going to be a 1 here and square root of 2. And remember this also, that it's positive or negative, so the negatives are just fine here. -1, square root of 2. And we know all these middles are just 1. Now the other thing about this is one of our special triangles. Hopefully you noticed that. So then for the first quadrant here, this one here, this is going to be pi fourths, because we're still dealing with radians here. Okay, so that's pi fourths. So my first answer for this is going to be theta equals pi fourths. Now to find the next one, keep in mind here that all of these angles here, all these angles inside of these triangles are pi fourths. Okay, but what we need here is we need to know what this angle is next. Now think about this. If I went all the way here, this would be pi. If I went all the way down to this side here, but I didn't. I stopped pi fourths short. So if I think of pi as 4 pi fourths, and I'm going a pi fourths short, that means my next value is going to be 3 pi fourths. And then I continue the same process. Now if I went even further and I went down to this one, this is going to be 4 pi fourths plus a pi fourths. So this is going to be 5 pi fourths. And then I do this one more time to go all the way around here. And then if I went all the way around, this would be 2 pi, or 8 pi fourths. And then one last, because this is pi fourths here, it's going to be 7 pi fourths. So in the directions, it gave us the same limitation as the previous problem that says, hey, I'm only looking for the answers between 0 and 2 pi. So these here would be those 4 answers.